Welcome back. Let's discuss my favorite order, that is Carnivora, and specifically carnivore in evolution. Members of the order Carnivora have invaded nearly every continent and ocean, evolving into bamboo-eating pandas, clam-eating walruses, and of course, carnivorous predators. Recent work has resulted in a well-reserved phylogeny of extant taxa, as well as for the many extinct clades. With this solid phylogenetic framework and their excellent fossil record, we know of nearly 3 times as many extinct carnivorine genera as extant genera. The Carnivora has proven to be a model group for addressing questions on evolutionary significance. This lecture introduces the major carnivorine clades and addresses evolutionary patterns. With over 260 living species, Carnivora is one of the most species-rich clades of mammals. It should be noted that the term carnivoran is a phylogenetic classification, in contrast to carnivore, an ecological one. Although the order is named after its carnivorous members, the dietary breadth of living members of the order Carnivora extends from frugivorous to insectivorous taxa, Durophagous taxa, as well as the eponymous hypercarnivorous taxa. Locomotor diversity is also remarkable, with aquatic, arboreal, terrestrial, and fossorial taxa. Felids are hypercarnivorous, with some of their distinguishing features including a short, blunt rostrum, retractable claws, well-developed carnassials, and reduction of the postcarnassial dentition. The earliest records of felids are from the Oligocene of Eurasia. Extinct felids are comparatively fascinating, including one of the most popular, Smilodon fatalis. Viverridae is a group of relatively generalized, medium-sized carnivorans restricted to the Old World. Civets have well-developed carnassials and long pointed snouts, and one of their most distinguishing characters is the presence of a perineal gland. The first hyenids appear in the early Miocene of Europe and Africa, quickly moving to Asia by the Middle Miocene and briefly invading North America in the late Pliocene. In contrast to the massive molars observed in most hyenids, Protellus cristala, the aardwolf, has drastically reduced their post-canine dentition to a variable number of peg-like premolars and molars. Herpestids are carnivorous, feeding on a variety of small vertebrates and insects, although they are sometimes associated with the ability of some species to kill snakes. The social mongooses are well known for having evolved complex social systems. The Malagasy carnivorans, Eurypleidae, diverged from Herpestidae between 18 and 24 million years ago. Cryptoproctopherox, a classic example illustrated in the figure you now see, is one such species and has evolved during the clade's isolation on Madagascar. Its compact brain case, large eye sockets, retractable claws, and specialized carnivorous dentition have led some taxonomists to associate it with the felids. Recent molecular analysis confirms Nandinidae's basal position among extant feliform clades. Previously thought to be a viverrid, despite its primitive bulla and basicranial morphology, it consists of a single species, Arctictis binturong, and its fossil record is poor. With approximately 9 genera, Nimravids, a wholly extinct clade, distinguished by their long, laterally compressed upper canines, mandibular flange, and reduced or absent M2, similar to saber-toothed felids, are well represented in the fossil record from the late Eocene in Asia and North America. Mustelidae is the most taxonomically diverse carnivore and family-level clade, with 107 recognized genera. Mustelidae presently includes many familiar animals, including otters, weasels, and badgers. They first appear in Eurasia, spreading to North America and Africa by the late Oligocene. Studies of mustelid evolution suggest that most of their diversification has occurred in Eurasia, with multiple invasions of the other continents from that region. They demonstrate specializations in the acquisition and consumption of prey, with one of the most interesting being sea otters, which extensively use rocks to break open shells of their prey. Although they are not particularly taxonomically diverse and are all medium-sized, primarily nocturnal, and at least partially arboreal, living procyonids, a clade that consists of 18 genera, do display interesting variation in both morphology and ecology. Perhaps the most familiar forms are the omnivorous raccoons of North America. As discussed by Morlow and Payne, 2010, molecular, morphological, and fossil evidence strongly supports Ailurids as a distinct clade, and many molecular studies place Ailuridae as the sister clade to other mustaloids. Only one species of Ailuridae survives today, Ailuris fulgens, which is quite specialized for bamboo feeding. New fossil Ailurids, having grown extensively in recent years, will have important implications for understanding the evolution of their exceedingly specialized extant relative. Mephitids, e.g. skunks and stink badgers, best known for the noxious odors they produce from their anal glands, are known from the early Miocene of Europe and the late Miocene of North America. Skunks persist only in the New World today, but stink badgers are found in Indonesia. Like most carnivorans, mephitids invade South America after the formation of the Panamanian land bridge in the late Pliocene. There are 4 extant and 11 extinct genera. Odobenidae, Otaridae, and Phocidae are pinnipeds, a monophyly that represents a major transition to a primarily aquatic life. A recent discovery of an early Miocene pinniped from the Canadian Arctic provides an exceptionally preserved transitional fossil. Pugilardini shows several skull characters linking it to pinnipeds, but has large, possibly webbed feet and an unspecialized tail. Odobenids continue to use quadrupedal locomotion in the water, while phocids use hind limb-powered swimming, and otarids rely instead on their forelimbs for propulsion and maneuvering in the water. With only 5 genera and 8 species, ursids are not speciose. However, Ursidae has a long fossil record, with circa 20 extinct genera ranging back to the Eocene. Bears and their fossil relatives are typically divided into 3 chronologically distinct groups. Amphicyonidae, a paraphyletic group from the late Eocene to the early Oligocene of Europe, Asia, and North America. Hemicyoninae, from the early Oligocene to the late Pliocene of Asia, Europe, and North America. And Ursinae, from the early Miocene of Asia, Europe, and North America, spreading to Africa in the late Miocene and to South America in the early Pleistocene. Amphicyonodines are dog-like animals, remaining generalized. Hemicyonines, alternatively, evolve a large body size and predatory morphology, with a digitigrade stance that suggests that they were capable runners. These specialized bears disappear before the end of the Miocene, whereas their generalized relatives were left to continue. Ursinae is a clade of omnivores, although some species do exhibit extreme specializations. Pandas, for example, are well known for bamboo feeding, while sloth bears predate termites. Polar bears are entirely carnivorous. For a clade of only 8 extant species, bears clearly show remarkable ecological diversity. Canidae, with approximately 47 genera, and one of the best fossil records dating from the Eocene, is diverse. The earliest canids are the Hespericynons, with 10 genera known from the Eocene to the Miocene of North America, while the earliest forms are small, large hypercarnivorous forms evolved during the Oligocene, with Hespericynines achieving their maximum diversity in the late Oligocene. Borophagines appear in the Oligocene, exhibiting their maximum diversity in the Miocene, during which 13 of the approximately 15 recognized genera exist. Although borophagines are typically thought of as bone crackers, similar to modern hyenas, this morphology really characterizes the later forms that dominated in the late Miocene and Pliocene, e.g. Epicyon, which was bigger than a Canis dirus, bigger than Panthera pardus, and nearly as big as Panthera leo. By the late Miocene and into the Pliocene, Borophagenes quickly decline, likely due to competition with canines, and the bone-cracking forms are the last of the Borophagenes radiation to go extinct at the end of the Pliocene. Canines are the only extant canid radiation with approximately 13 extant and 7 extinct genera. Canines first appear in the early Miocene of North America, spreading to Europe in the late Miocene, then to Africa and Asia in the Pliocene. Canines' generic diversity remains low for most of the Miocene, with a pulse of diversification in the late Miocene, correlated with the decline in Borophagine diversity in North America, and a larger pulse, particularly in species diversification in the early Pliocene. With a marathon runner's physique, these gregarious animals are specialized for long-distance pursuit. The extinct Amphicyonidae, or bear dogs, is taxonomically diverse with 34 genera and a long fossil record spanning the Eocene to the Miocene. Amphicyonids first appear in North America and Eurasia in the Eocene, invading Africa in the Miocene. These large-bodied predators, as their name suggests, have much in common with both canids and ursids, particularly in terms of dental and locomotor morphologies. While earlier forms appear to be more cursorial, like canids, later Amphicyonids display a more ursid-like semi-plantigrade stance. The dentition of Amphicyonids was relatively homogeneous, with small mesial premolars, large carnassials and robust past carnassial teeth, suggesting a diet ranging from omnivorous to relatively hypercarnivorous. Because of their living diversity and excellent fossil record, Carnivora has been the focus of many studies in recent years. The understanding of carnivoran evolution involves resolving the relationships of the living and extinct species, providing a framework for more detailed study of their evolutionary history. A strong phylogenetic framework is essential to rigorous assessment of evolutionary trends, to isolate the effects of external influences from patterns that simply reflect ancestral conditions. Teeth reflect diet and ecology. The early fossil record of carnivoran dentition shows that diversity increased rapidly in the early Cenozoic. Even what we think of as a highly specialized morphology, saber-toothery, evolved independently in both Felidae and Nimravidae. This lack of novelty in the carnivoran record perhaps reflects the stability of prey as a food source. Large cat-like forms have evolved in at least 6 different families, from short-faced bear dogs to leopard-sized mustelids. Bone-crapping forms have evolved at least twice, in hyenas and dogs. However, despite the repeated evolution of hypercarnivorous forms, it has been demonstrated that hypercarnivory is often an evolutionary dead end. Large hypercarnivorous forms diversify quickly, but also decline and go extinct quickly. Well, I hope you've enjoyed that lecture on carnivorans as much as I have. I'll see you again when this time we discuss TNT and its use. Thank you.